Good morning, Year 6. This is my first attempt at doing a video lesson. Unfortunately, I don't have access to a webcam, so it's just going to be my voice, so you don't get to see my face. However, that could be a good thing. So I've had a look at the activities that you've done on SATS Companion over the last couple of weeks, and I've looked at areas that some people may have struggled with a little bit. So we're going to be doing some recapping and revision on those areas, and I'm going to be giving you some tasks to do. So you should already have a pencil and paper with you. So the first thing I want you to do is a quick recap of what the following things mean or how you can do them. So first of all, what does the word percent actually mean? Secondly, how can you convert tenths to hundredths quite easily? And then why is it easy to convert 50ths to hundreds, and what other fractions are easy to convert to percentages? So if you press pause, answer those questions, and then when you're done, press play. Okay, so the word percent means out of 100. So per means out of, and then cent means 100. So how can you convert tenths to hundredths? Well, tenths is obviously out of 10. Hundredths is out of 100. So what you need to do is to convert from tenths to hundredths, you're multiplying the denominator by 10. So you also multiply the numerator by 10. So 1/10 is the same as 10 hundredths. If it was 2/10, it would be the same as 20 hundredths. And then, because that's out of 100, you can easily convert that to a percentage. So 1/10 equals 10 hundredths, which equals 10%. 2/10 equals 20 hundredths, which equals 20%, and so on. Why is it easy to convert 50ths to hundredths? So similarly, if you've got a 50th, you do whatever you do to the denominator, you need to do to the numerator. So from 50ths to hundredths, we're multiplying by 2. So you need to do the same to the numerator. So for example, if you've had 20 out of 50, you would multiply your 50 by 2 to make 100, and then you would multiply your 20 by 2 to make 40. So 20 50ths is equivalent to, or the same as, 40 hundredths, which therefore equals 40%. And then it says what other fractions are easy to convert to percentages. So there's a range of different possibilities there. It's anything that is easy to multiply the denominator to get to 100. So for example, if it was 20ths, you should know that to get 20 into 100, you times it by 5. And just remember that whatever you do to the bottom number, the denominator, you need to do to the numerator. Okay, so we're going to move on to some fluency now. I'm going to give you some activities like I just did, and on each one you're going to pause it, have a go, and then we'll go through the answers. If you do struggle with it, don't worry, have a go, and then I will be explaining it on the following slide. So, converting between fractions and percentages. Starting off quite easy then, it says what fraction of each 100 square is shaded. Write the fraction as percentages. Now this is easier because obviously they are on 100 squares, so it's already out of 100. So for those two, just how much of it is shaded in blue. How much out of 100, and then change it into a percentage. Then we've got complete the table. On this one, you don't actually have to do any converting because these fractions, 1/2, 1/4, 1/10 and 1/5, they are all fractions that you should automatically know as a percentage and actually as a decimal. So you should just know what they are. And then at the bottom, fill in the missing numbers. So some of them are already out of 100, so that's fairly straightforward. If it's not out of 100, then you need to see what you've done. So for example, 12 50ths, what have you done to the 50 to convert it into 100? So you must do the same to the 12. And then the bottom one, it's 44 what equals 2200. So for that one, what have you done to 44 to convert it into 22? So that must have been what you've done to the same one. You might need to work backwards for that. So you times 22 by 2. So what do you do to the 100? Okay, pause it, have a go, and then press play to check your answers. Okay, so top one then, 20 out of 100. 20 of the 100 squares are shaded blue, so that's 20%. And then on the second one, there are 74 out of 100 shaded blue, so that's 74%, quite easy. Like I said, for this one you should automatically know these, so you should know that a half is equivalent to 50%, a quarter is equivalent to 25%, a tenth is the same as 10%, and 1/5 is the same as 20%. Filling in the missing numbers at the bottom, the top two are probably the easiest, so 12 over 100, so it's already out of 100, so it's 12%. And then it was what out of 100 equals 35%, so you should have got 35. Then we had 12 over 50, so for that one, if you multiply the 50 by 2 to get 100, you need to do the same to the 12, multiply that by 2, and you would get 24, so it's 24%. And then for the last one, what have you done to 44 to get it to 22? You've actually divided it by 2. Or doing the inverse, working backwards, what have you done to 22 to get it into 44? Because we're going to be converting our 100 going backwards. So we've times 22 by 2 to get 44. So therefore we need to times our 100 by 2 to get 200. Okay? Next slide. So a recap now of converting from decimals to percentages. So we've just done converting from fractions to percentages. Now we're going to add an extra step. So we're going to do a decimal point, then a fraction, then a percentage. Okay, so it says, how does converting a decimal to a fraction help us to convert it into a percentage? Well, first of all, if we convert it into a fraction, we can see what it is out of 100, and then that makes it a little bit easier. So how do you do it then? So 0.2. You look at what column that 2 digit is in. It's in the tenths column, so that is equivalent to 2/10, which is, like we've just discussed on the previous slides, the same as 20 out of 100. Therefore, it is 20%. 0.35 is the same as either 3/10 and 500 or 3500, which is the same as 35%. Okay? So you convert your decimal into either tenths or hundredths, and then you can easily see what it is as a percentage. So using that knowledge then, it says complete the tables. The top one's been done for you. 0.35, like we just said on the previous slide, that is equivalent to 35 hundredths. So 35 out of 100 is obviously 35%, because like we said, percent is the same as out of 100. So 0.27, what's that as a fraction? What is it as a percentage? 0.6, 0.06. Then for the question 2, we've got use less than, more than, or equals to complete the statements. So for this one, you've got a mixture of decimals, percentages and fractions. So before you even think about trying to compare them and add your symbols in, the first thing you need to do here is to convert either your decimals or your fractions into a percentage, so that you're only working with one. So you've only got percentages, because if you're trying to compare them while they're mixed between decimals, percentages and fractions, it's going to be a bit complicated. So for example, for the first one, you're going to convert your 0.36 into a percentage. Then you can easily see which one is bigger. Going across for the second one, 7/10 and 0.07, you're going to have to convert both of those into a percentage, and then you're going to have to do the same for the bottom right, 0.4 and 1/4, and then for 0.4 you've just got to change that one because you've already got 25%. And then the last question on this side is, which of these are equivalent to 60%? So again, for each one you need to convert it into a percentage, and then you can figure out which one or which ones are equivalent to 60%. So pause the video, have a go. When you're done, press play. Okay, so let's have a look at the answers then. So 0.27 is the same as 27 hundredths, which is the same as 27%. 0.6 is the same as 6/10, which is equal to 60 out of 100, which is 60%. And then 0.06, well that 6 there is in the hundredths column, so it's the same as 6 out of 100, which is 6%. Moving on to question 2, we convert our 0.36 to 36% because it's the same as 36 hundredths. then we can see that 36 is less than 40. Going across, our 7/10, we can convert it into 70 out of 100 and then 70%. And our 0.07 we can see is 700, which is 7%. So therefore you can see that 70% is more or greater than 7%. 0.4 is the same as 4/10 or 40 hundredths. So that's 40%. We've already got our 25%, so we don't need to do anything there. And 40% is greater than 25%. And then finally, we've got our 0.4 or 4/10, which is the same as 40 hundredths, 40%, and then for our quarter, you should automatically know that that one is 25%. 40% is greater than 25%. Which of these are equivalent to 60% then? Okay, so we've got 60 out of 100, so we should know automatically that that one is 60%. 6 out of 100, again, it's already out of 100, so we should know that that's 6%. Going across then, 0.06, if we convert that to a fraction, look at the 6, it's in the hundredths column, so it is the same as 6 hundredths. 6 out of 100 is the same as 6%. 3/5. So for this one, first of all, we need to convert it to tenths. So we say, right, what do we do to 5 to convert it into 10? Well, we multiply it by 2. So we must do the same to the 3. So 3/5 is the same as 6/10. Then, what do we do to the tenths to change them into hundredths? Well, we times it by 10. So 6/10 is the same as 60 hundredths. So therefore, that one is equivalent to 60%. 3/50ths. What have we done to our 50 to get it into 100? We've times it by 2. So we must do the same to the numerator, which is 3. So 3 times 2 is 6. So it's 6 out of 100, which is 6%. And then we've got 0.6, which if you look at that 6, it's in the tenths column. So it's 6/10 or 60 hundredths. So that one is also 60%. So which of these are equivalent to 60%? You should have got 60 hundredths, 3/5, and 0.6. Any of those that you've not got right, if you correct them, so you might want to just pause it again to correct it, but don't forget there's also a chance to come back and re-look at the explanations if you struggled with it. Okay? Next slide. Again, we're using less than, more than, or equals, but in this one we're comparing 3 different numbers. So we've got 60%, 0.6, 3/5, then we've got 0.23, 24% and 1/4, 37.6%, 3/8 and 0.27. And again, for that I suggest that you convert them all into percentages first. Now the third one there, 37.6%, 3/8 and 0.27, is a little bit more tricky. So I'm going to give you a little clue. For the middle bit, 3/8, if you think to yourself, right, 1 whole is 100%, a half is 50%, a quarter is 25%, then an 1/8 is going to be 12.5%. So if 1/8 is 12.5%, what will 3/8 be? Okay, so 1/8 equals 12.5%, so what will 3/8 be? And that should help you with that last one. And then for the second question, order them from smallest to largest. So again, if they're already percentages, you can leave them as they are. If they're not, then you need to convert them. Okay, pause it, have a go, and then let's go through the answers. Okay, so we're using less than, more than, or equals to complete the statements. So 60% is already a percentage. 0.6 is 6/10, 60 hundredths, 60%. 3/5, and actually you could have used some of your information from the previous slide for this, or some of you working out. 3/5 is the same as 6/10, which is the same as 60 hundredths, so that is also 60%. And you can see there how I've worked it out. So you can see that from 3/5 I've times it by 2 to get it to 6/10, then times it by 10 and it's 60 hundredths. So they are all equal, so therefore you need equal symbols in both of those circles. Okay, the next one, 0.23 is the same as 23 hundredths, so it's 23%. 24% we're okay with, and a quarter we've already said is the same as 25%. So therefore, it is going up by 1% each time. So 23% is less than 24%, which is less than 25%. For the last one, we've got 37.6%, and then I told you that 1/8 was the same as 12.5%. So 3/8 must be 12.5% times by 3, which is 37.5. So we've got 37.5 in the middle, and then at the end we've got 27 hundredths, which is 27%. So we've got 37.6, 37.5 and 27. So in this example it is going down. So 37.6 is greater than 37.5, which is greater than 27%. Again, if you've not got those right, make your corrections. Pause it, have a look at the explanations and make sure you understand it. And then we'll move on to the last one. So order from smallest to largest. So before we can do that, we need to convert the ones that are not percentages into percentages. So 2/5, so we times that by 2 to make it into 4/10, and then we times it by 10 to make it into 40 hundredths. 40 out of 100 is the same as 40%. 0.45 is the same as 45 hundredths, so that's 45%. 3/10 is the same as 30 hundredths, so that's 30%. 54% is already a percent, so we don't have to do anything. And then 0.05 is the same as 5 hundredths, which is 5%. So now we've got them all as a percentage, we can compare them more easily. So if we're ordering them from smallest to largest, the smallest is obviously 5% or 0.05. Then going up, we've got 3/10 or 30%, 2/5 or 40%, 0.45 or 45%, then we've got 50%, and finally 54%. Give yourself a mark if you've got those correct, if not, make the corrections. Okay, so we're going to move on to some problem solving and reasoning. Now, I'm just going to say, if you found the fluency quite tricky, okay, don't worry about doing the problem solving and reasoning. So if you are in maybe Miss Hessery's purple group, or if you are in one of the groups that goes out with Miss White or Miss Croak, if you're struggling, or if you found those quite tricky and it's taken you quite some time to complete them, don't worry about doing the problem solving and reasoning, because you've probably done enough for today. If, however, you did the fluency and you thought, yeah, that was really easy, I know what I'm doing, I got most of them right, then we're going to have a go at the problem solving and reasoning. What I don't want is for anybody to get all worked up and frustrated. So please, 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 if you are struggling, don't worry, you don't have to move on to the problem solving and reasoning questions. Okay? So, let's have a look. In a maths test, Tommy answered 62% of the questions correctly. Rosie answered 3/5 of the questions correctly. Who answered more questions correctly? So for that, you're going to have to convert them so that they are both percentages, okay, and explain your answer. Then on the question 2, Amir thinks that 18% of the grid has been shaded. Dora thinks that 36% of the grid has been shaded. Who do you agree with? Explain your reasoning. So pause it, have a go, and then press play. Okay, so in the maths test, Tommy answered 62% of the questions correctly. Rosie answered 3/5. So we've already got Tommy's as a percentage, we just need to convert Rosie's to a percent. So to convert Rosie's into a percentage, we need to times it by 2, which is 6/10, then times it by 10, which is 60 out of 100, which is 60%. So Tommy scored 62%, Rosie scored 60%. So therefore, Tommy answered more questions correctly because 3/5 as a percentage is 60%, and this is less than 62%. Okay, if we look at the boxes then that are shaded, if you count them all going across, they're in 5s, so it's 5 lots of 10. So altogether there are 50 squares on that grid. And there are 5, 10, 15, 16, 17, 18 of them are shaded in green. So that's obviously where Amir has got his 18% from. However, it's only 18 out of 50. So what do we need to do? Well, 18 out of 50, what do we do to 50 to make it so that it's out of 100? We times it by 2. So we need to do the same to that 18 to make it into 36. So 18 out of 50 is the same as 36 out of 100, which is 36%. So Dora is correct because 18 out of 50 is 36 out of 100, which is 36%. Okay? Amir says that 0.3 is less than 12% because 3 is less than 12. Explain why Amir is wrong. The bottom one now is a bit more tricky, so this is probably just for Miss Heshry's greater depth group. Okay, so 4 friends share a pizza. Whitney eats 35% of the pizza, Teddy eats 0.4 of the pizza, Dora eats 12.5% of the pizza, and Alex eats 0.125 of the pizza. Write the amount each child eats as a fraction. And then when it says this bit, who eats the most, who eats the least, and is there any left? I suggest you then convert back to percentages to work those bits out. Pause it, have a go. Okay, so Amir says that 0.3 is less than 12% because 3 is less than 12. It already tells us he is wrong, but it wants us to know. It wants you, to explain why he is wrong. So Amir is wrong because 0.3 is equivalent to 3/10 or 30/100, which equals 30%. Therefore, 0.3 is more than 12%. Right, this one's tricky. If you couldn't do it, don't worry. Or if you've only done half of it. 4 friends share a pizza. Whitney eats 35% of the pizza, Teddy eats 0.4 of the pizza, Dora eats 12.5%, and Alex eats 0.125. Write the amount each child eats as a fraction. So for Whitney and Teddy, it's quite straightforward because we can see that Whitney's got 35%, so it's 35 out of 100. Teddy eats 0.4, which is 4/10 or 40/100. So I'm just going to do the next bit on the next slide. Dora eats 12.5% and Alex eats 0.125. Now 0.125 also equals 12.5%. It's going to be difficult to write 12.5% as a fraction because you can't put 12.5 out of 100. So the best thing to do here is say, right, between them, so if we add Dora and Alex's together, 12.5% add 12.5% equals 25%. So between them, they've eaten 25% of the pizza. And then we say, oh, well, I know that 25% equals a quarter. So if 25% equals 1/4, which you can see there on the left, 1/4 split equally between 2 of them, then makes 1/8. So 25% equals a quarter. Split that equally between Dora and Alex, that means they've got 1/8 each. So as a fraction, Dora has had 1/8 and Alex has had 1/8. Okay, and then together they've had 1/4. Oops, that's why then, when we come on to this one, because we've got them as different fractions, so Whitney's is out of 100, Teddy's is out of 100, Dora's is out of 8 and Alex's is out of 8. So therefore it's going to be tricky for us to say who ate the most and who ate the least. So that's why we then need to go back to using percentages. So Whitney had 35%, Teddy had 40%, we know that Dora had 12.5% and Alex also had 12.5%. So who eats the most? Teddy eats the most. Who eats the least? Dora and Alex both eat the least. Okay, I've not actually written that one on, but the answer is that Dora and Alex both eat the least. And then it says, is there any left? So now, because we've got percentages, we can easily see if there's any left, because the 100% is the whole pizza. So if we add up how much each of them have eaten, 12.5 add 12.5 add 35 add 40, that actually gives us 100. So 100% of the pizza is eaten. Therefore, there is no pizza left. Okay? Like I said, that one is a tricky one. If it's completely thrown you and you're not sure and you don't get it, don't worry. Okay? The thing I'm most concerned about, is the fluency that was at the start of this video. And then this is an extension challenge. I'm not going to read this one out for you. This is just to do if you're feeling super confident. Have a go at it yourself, pause the video, and then your answers will follow.